Hey everybody, this is Mr. Plunkett, and this is Chapter 3, Section 4, Extension, Factoring Expressions. Okay, how is factoring, there we go, an expression like reverse distributive property, which is what we learned about last lesson. I have to write down here because I don't have enough space. So that's the essential question. How is factoring an expression like reverse distributive property? So let's go through the key idea here. After you write that down, some of you are probably still writing it down. Remember, you can pause this video. Okay, factoring an expression. Writing a numerical expression or algebraic expression, that's one that has a variable, as a product of factors is called factoring an expression. You can use distributive property to factor expressions. So here's what we have in the numbers here. 3 times 7 plus 3 times 2 is the same as 3 times the quantity 7 plus 2. Because we learned last lesson that when you have a factor multiplying parentheses, that factor multiplies all of the terms inside the parentheses. So algebra goes, okay, if there's an A multiplying B plus the same number A multiplying C, you can factor out that A so that it's A times the quantity B plus C. That might seem a little strange. I mean, it works for subtraction too, but why don't we take a look at an example, and I think you're going to start to get it. How can I factor, okay, wait, I'm factoring expressions, kind of like reverse distributive property, two terms using the GCF. Okay, factor 20 minus 12 using the GCF. So here's 20 minus 12. What I need is a number that is a factor of 20 and a number that's a factor of 12, right? The greatest common factor. And I'm going to factor that out. So what would be the greatest common factor of 20 and 12? And I don't know if you guys remember this, but what we used to do was, and I'll make a little wall here, we used to write a list of factors for each number and figure out what the greatest factor is in each list. So we have 12, we have 20, we have a colon. Okay, 1 times 12. Remember factor pairs. You can use a multiplication chart to find these. 2 times 6. And then we have 3 times 4. I leave myself a lot of room, but you see those are all the factors of 12. And then we have 1 times 20, and then you can tell 20 is even, so that's 2 times 10. And then we have 4 times 5. And I'm not leaving myself enough room here. I'm going to put the 5 down here, comma. And we look for what is the greatest factor in both lists. Well, 1's in both lists. That's a common factor. 2's in both lists, another common factor. 3 is not in both lists, but 4 is. So 4 is in both lists. 6 isn't in both lists. 12 isn't in both lists. Neither are 5, 10, and 20. So the greatest common factor must be 4. So I'm going to write GCF is equal to 4. Okay, that means 20 can be written as 4 times 5 minus 12 can be written as 4 times 3. So if 4 is a factor of both numbers, we can factor it out. It's like a reverse distributive property. We're going to factor out the 4. So out here, we're going to have the 4, and then we're going to have parentheses. And here's kind of the hard part to make sure we understand. This is 5 minus 3. And the reason it's 5 minus 3 is if you went backwards. Now, this is actually the answer to the question, 4 times the quantity 5 minus 3. But if we went backwards, 4 times 5 is 20. Minus 4 times 3 is 12, right? So we've kind of taken an expression that's already had the distributive property done to it, and then we're undoing it. We're going backwards to where the problem was before we used distributive property. Okay, remember that factors are the numbers that blank together to make a product. How do we get a product? We multiply numbers. Find the GCF of 12 and 20 using the ladder or list method. We didn't do the ladder this year. We just did the list method. And then we use blank blank to write the expression as a product. We use the distributive property, kind of backwards, distributive property to write the original 20 minus 12 as a product. That means 4 times the quantity. All right, that's the end of part 1, and I'll be right back for part 2.